Today's objective, simplifying expressions by combining like terms. Let's begin. Let's take a look first at the difference between x to the second power, and x to the third power. Now this is an unknown length at this point. We don't have a ruler to measure it, so we're going to label this length x. So when you think of x, think of an unknown length. Now, if I take that length and multiply it by a width of the same measurement, I'm going to get a square. And what's the space inside that square? The area is x times x, which is x to the second power. Now, x to the second power often has a nickname, x squared, and often anything to the second power is squared. And the reason why it has that nickname is because the width and length, which are the same, when multiplied together, will form a square. Simple as that. Now, if I add a third dimension of x, I'm going to get a cube. And you could probably guess what this thing's called, x to the third power, or x cubed. Now, all three of these are different. They're different shapes. And we're going to consider these different terms, or unlike terms. Unlike terms are terms that have different exponents. But they could also have different variables. Notice these all have x. How about another length that is unknown? We're going to call this y. Notice it's different than the length of x. It's still unknown. These are also considered unlike terms. And so, for instance, would a y squared would be different than an x squared. So if we're looking at like terms are terms that share the same variable factors. Here's some example of like terms: 2x, negative 4x, x, or half x. The variable factors, variable being letter, and factors, values being multiplied. This letter is being multiplied with a 2. This x with the negative 4, this x with an unknown, actually not unknown, but an invisible 1, and this x with the 1/2. These share the same variables. It also has the same exponent, an invisible 1 up here. We have one factor of x for each of them. So these are all like terms. Over on the right column, these are examples of unlike terms. Y, 7n, x to the third power, 2x squared. They have different letters, different variables, so they're unlike terms. And the ones that do have the same letters or variables have different exponents. And as we saw before, an x cubed is a lot different than an x squared. Now, like terms can be combined. Think of them as Legos that are alike, and we can click those guys together. So if I take 2x, negative 4x, 1x, and 1/2 x, I get negative 1/2 x. But over here, when I add y, 7n, x to the third, and 2x squared, they're unlike terms. I can add them, as you see, with the plus signs, but I cannot connect them or combine them. So often you'll hear people say, you can only combine like terms. And you combine them by adding the coefficients. And the coefficient is the number in front of that letter. Let's do an example. How about x plus x? That would be 2x. It's like an apple plus an apple. You have two apples. Well, an x and another x is two x's, and that's how we're going to write it. Oh, we have a Lego guy there.
The number in front of a variable is called the coefficient.
It's right there, like the Lego guy is saying. The 2 is in front of that x. We're going to call that a coefficient.
The coefficient tells you how many terms of x you have. In this case, you have 2 terms of x. X plus x is the same as 2x. The coefficient literally is the number times the variable. 2x is 2 groups of x. If we add y to the initial expression, it cannot combine with the x.
Oh, I see. So x plus x, we can combine those because they're like terms, and we get 2x. We combine the coefficients, an invisible 1 plus an invisible 1, 2x. But we can't combine it with the y because they're unlike terms. We just leave it alone.
If we add x to the second power to the initial expression, it cannot combine with the x.
Oh, okay. So if I try this one, these x's will combine because they're like terms, but we can't combine it with the x squared. Now I used the commutative property of addition right here. I put the 2x in the back and the x squared in the front. We can switch the order of these if we want to. Generally, the term with the largest exponent comes first.
But if we add negative 7x to the initial expression, it combines with the 2x.
Oh, okay, so we get negative 5x.
What is the coefficient? That's right, it's negative 5.
All right, try your hand at these. If I have 3x plus 7x, I have 3x. I'm going to use these blue strips to represent the x. I know I used red earlier, but I'm going to use blue here. Blue for positive, and I'll use red if we get some negatives. And I have 7 x's. Remember, x being these unknown lengths. So 1, 2, 3 x's plus 1, 2, 3, 4, 5, 6, 7 x's. So how many x's do we have altogether? We have 10x. All we do is we add the coefficients. And 3 plus 7 is 10. How about this? 2x minus 5x plus x. Now, the coefficient 2 in the first term says we have 2 x's. This minus 5x is stating that we have plus a negative 5x. Remember, subtraction in front of a term denotes that we have a negative term here. We're adding a negative 5x. So that's why I denote those with red. We have 5 negative x's. And we have another positive x. Now I'm going to combine the positives, giving us 3 positive x's, and I have a negative 5x. We combine those. We have more negatives than positives, so the simplified version would be negative 2x. One more. How about this? We have 2x squared plus 3x squared plus x plus 5x. We have 4 terms, and we have x squareds and x's. The first term says we have 2x squares. And we're going to add 3x squares. Notice they're squares. They're blue, they're positive. And I have 1 positive x, and I'm going to add 1, 2, 3, 4, 5 x's. Now when I combine the x squareds, I have 5 of them. And when I combine the x's, I have 6 of them. So this would be 5x squared plus 6x. And these are examples of taking an expression and simplifying it by combining like terms.